What is up, everybody? Welcome back to my channel. Today in this video, we're going to talk about how we can derive three of the most commonly seen log properties from exponent properties. Now, remember, logarithms offer us a different way, an alternative way of expressing an exponential. For example, 3 squared equals 9. If we want to put this in log form, we would say, well, log base 3 and log equals exponent, right? Now 2 is on the other side of the equation, and the argument is 9. Okay? This is what we call the argument of the log, and the 3 is the base, right? Log base 3 of 9 equals 2. Now, if we take a look at the two equations here, they're really expressing very similar ideas. It's just that the order are kind of been switched. They're asking different questions, right? The first one, this equation is asking, what is the answer to 3 squared? Well, 3 squared is 9, so the answer is 9, right? The second one with the log, all right, this log is asking, well, what is the power? What power do I need to raise 3 to so I can get 9? Well, 3 squared gives you 9, so the answer to this logarithm here is 2. Right? As you can see, they're very similar. Now, if we move over to the properties here, when you compare the properties of exponents and logarithm, you can find a lot of similarities, right? We got the product here, and now two exponentials multiply, and it becomes a sum in the exponent. For log, it's 2 logs. When you add the 2 logs, it becomes a product in the argument, right? Kind of similar. And here, same thing, right? Or the two exponential being divided, and it becomes a subtraction in the exponent here. And for log, it's kind of like the opposite, right? We have the 2 logs being subtracted, it becomes a division in the argument. Now, power to a power rule, we can multiply when we something to a power, and then to another power, we can multiply the power. For log, we can bring, right, we have the argument is n to the n. We can bring the n to the front as the coefficient. It becomes a product, right? N times log. So, as some of you might already know, that exponential and log are inverses of each other, right? So these properties here are really showing that inverse nature. So without further ado, let's get right into it. Let's talk about how we can derive these log properties using the exponent properties. So we're going to start off with some exponential equation. Let's say we have b to the power of x equals m. And then let's say we have another equation with the same base, b to a different power of y. And of course, it will yield a different answer, which is, let's call it n. Right? So now what I'm going to do is I'm going to put it in log form first. I'm going to put both of these equations in log form. This is going to be log base b of m equals x. Right? This one will be log base b, right, equals the exponent y, and the argument is n. Okay, I'm going to convert them into log form and then put them aside. Okay, we're going to come back to those. Now, since we're trying to make the connection from the exponent property to the log property, we want to have something that looks like this, right? B to some power times b to another power. So here, if we want to get that, so why don't we just multiply the two equations, right? If we multiply the two equations, on the left-hand side, we'll have b to the x times b to the y. So now we have exactly that. And it equals, on the right-hand side, we'll have m times n. Now, according to the exponent property, this is going to be b to the x plus a, and then m times n. And now what I'm going to do is I'm going to put this in log form. Log base b, right? Log equals exponent x plus y, and this will becomes the argument m times n. Okay, now remember what is x and what is y, right? So if we do the substitution here, log base b of m times n will equal to, well, x is really just log base b of m plus y is log base b of n. And there we go. There we have it. All right, that's our first property right over there. And now, if you want to derive the quotient property, we're gonna have exactly the same setup. So now, instead of multiplying the two equation, we can divide the two equation, and then we can do substitution at the end. So I'm gonna leave a quotient rule to you, quotient property to you. Okay, you can work through the proof for the second one on your own, very similarly, right? So now let's talk about the last one, power to a power rule. Okay, so now again, okay, we're gonna start with some exponential equation. Since we want to make the connection again, right, from exponent property to this property right over here, I want something. I want a power to a power. So why don't we just raise both sides of this equation? Actually, before I even do that, okay, before I do that, I'm gonna convert this into log form first. Okay, let me convert this into log form. Log base b equals exponent, and the argument is m. Okay, I'm gonna convert it to log form, put it aside. Okay, now let's raise both sides to the power of n. All right, and according to the property, this is going to be b to the n times x equals m to the nth power. And once again, I'm going to put this in log form, log base b. Now we're gonna treat this as an entity. I'm gonna treat this as a whole. So now base b, the exponent is really nx, and now this whole thing will become the argument of the log, right? Now actually, let me rewrite this. Okay. Now remember, what is x? Remember, what is x? If we substitute, we're going to have log base b m, right? M times log base b of m. And there we go. Okay? So now we've derived all three log properties here from the exponent property. I hope you guys enjoyed today's video. I'll see you in the next one. Peace.